Hey y'all, welcome back to another video of Mrs. Perry with crazy hair, and yeah, it's great. Today we're gonna start with some math. Please open your textbooks to page 40. We're going to talk about estimating, either subtracting or adding decimals and estimating them before we actually do the work, right? Estimation helps us if we can do it kind of quickly in our heads or even on paper. It helps us to check against our real answer to make sure that it makes sense. Because let's say we do a problem and we get this answer, but it doesn't seem quite right. We can use estimation to make sure, oh yeah, that makes sense that that's what the answer is. Or no, it doesn't. Or even better, use estimation first. So estimate what the answer might look like, and then when you actually do the problem, if it's way far away from what you estimated it would be, you know, maybe I should try that again. Maybe there's something wrong with either my math or my estimation. But it helps you to double check and know that you need to double check because something might be not quite right. So we're on page 40. We're going to, estimation, really, you can estimate in a number of different ways. There's no one strategy. And usually it's by rounding. So it's just how you feel comfortable rounding a number to be able to do it in your head. I like to round to whole numbers because, like I said, I'm not great at doing math in my head. And so that's something I know probably I need to work on. Also, I just know that's how I'm made, and I've got to give myself a little extra grace when it comes to doing math in my head. So I like to round to whole numbers because whole numbers are a lot easier to work with than decimals. But you could also round, say you have a 2-place decimal, you could round to a 1-place decimal. Right? Just know with rounding, let's just practice some rounding. So this is let's start with number 29 on page 40. It wants us to add 8.67 plus 7.2, but first let's just focus on rounding. So I just have 8.67. If we were to round this number to the nearest tenths place, right, we would look at our hundredths place. Can you see the decimal even on this? The sun's finally shining, so I might have to write bigger. So if I was rounding to my nearest tenths place, I would look at my hundredths place to know to round up or keep things the same. So if this in my hundredths place was a 5 or larger, which it is, right, it's a 7, we're going to round my tenths place up. So this rounded to my nearest tenths place would be 8.7, right? Let me just change this number. If it's a 4 or lower, right, we don't round down, really. We don't change this number. We don't make it a 5. That would be wrong. We just keep it the same. So this rounded to the nearest tenths place would be 8.6. Now let's round 8.67 again, but to the nearest ones place. So if I'm rounding to the ones place, I look at the tenths place. This number is irrelevant, so you can ignore it. It's not important if we're rounding to the ones place. We just look at our tenths place. If this is 5 or larger, which here it is, we round up. So 8.6 is closer to 9 than it is to 8. And that makes sense, right? If we had a number line, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We had a number line, and this is 8, and this is 9, and we have 8.1, 8.2, 8.3. Oops. I don't really have room for this. 2. I'll write them upside down. Not upside down, but 8.5, 8.6, 7. It's kind of a mess. But if 8.6 is here, it makes sense, right, that it's closer to 9 than it is to 8. Okay? So that's rounding to ones places. So if we're going to round to, like I said, I like to round to whole numbers. So if we were to estimate and then add 8.67 plus 7.2, I kind of, in my head, want to round both of these numbers to the nearest ones place. We've already rounded 8.67 to the nearest ones place. 6 is higher than 5, right? So we're going to round our 8 up to 9. And 7.2. Okay. Oh, my decimals aren't showing up in the sun. 7.2. So I have my 7. I'm looking at my 10th place to determine if I round up or keep it the same. 2 is less than 5. So 7.2 is closer to 7.0 or 7 than it is to 8. So it's going to stay the same. So really, after my estimations, it's like I'm adding 9 plus 7. Well, what's 9 plus 7? 16. Okay? That's my estimated answer. It's not the exact answer. It's just an estimation. But it's something I can look at to see, oh, does my actual answer, when I actually do it, is it close to 16? Because if it's not, I'm going to have a problem. I'm going to shut this blind even further because I feel like there's a glare on my whiteboard. And that makes me sad and you wouldn't be able to see. Okay. Okay, hopefully that helped a little. I'm still trying to get some sunshine because the sun hasn't shined in forever. Okay. All right. So now let's actually do the problem by lining up our decimals. All right, so, oops, I'm going to need more room. Okay, just remember, let's remember, I'm going to write up in the corner and circle our estimation. Our estimation was 16. Now I'm actually going to do the problem. 8.67 plus 7.2. Okay, I've set up my problem, I've lined up my decimals, I've lined up my ones place, I've lined up my tenths place. I'm going to go ahead and write a 0 in my hundredths place so I don't get confused. That's especially important with subtraction. Okay, 7 plus 0, 7. 6 plus 2 is 8. And 8 plus 7 is 15. 15.87. That's pretty darn close to 16, isn't it? If we were to round this to our nearest ones place, right? 8 is greater than 5, so that would become a 6. So it's really close to 16. Okay, so that checks out. If I had gotten a totally crazy answer here, then I would have to redo it. And maybe my estimation was wrong, but maybe my math was wrong. So it helps us to determine when to redo something or when not to. Okay. Let's just skip on down to 34. Oh, let's do subtraction one first. So how about 33? So it wants us to subtract 1.99 from 5.62. Okay, I'm going to do the same thing that I just did. Now, what your textbook is saying, what little Ed is doing on the page, he's just rounding one of his numbers. He sees that this is really close to 2, which it is, right? And he just subtracts 2 from 5.62 to get 3.62. He felt comfortable doing that in his head, and I mean, he's a cartoon, but he felt comfortable doing it. And he got a very close estimate, a closer estimate than we would get if we rounded both of these numbers. But if, like me, you want to be, you're not as comfortable doing math in your head, you can round both of these numbers and then get an estimate. I'm going to round them both to the nearest ones place. So 1.99, again, if we're rounding to the nearest ones place, we just need to look at our tenths place. 9 is greater than 5, so we're going to round up to 2. 5.62, if we're rounding to the nearest one, we look at our tenths place. 6 is greater than 5, so we're going to round up to 6. And what is 6 minus 2? 4, right? Now, let's actually do it. Okay. I've lined up my ones with my ones, my tenths with my tenths, and my hundredths with my hundredths. I don't have enough hundredths to subtract 9 hundredths from, so I'm going to have to rename. So I trade in 10 tenths for, nope, that's not right. I trade in 1/10 for 10 hundredths, giving me 12. 12 minus 9 is 3. Now I don't have enough tenths to subtract 9 tenths from. I'm going to have to rename again. I'm going to trade in 1 for 10 tenths. Now I have 15 minus 9, which is 6. And now my ones place, 4 ones minus 1 is 3. Is 3.63 pretty close to 4? Yes, right? It would round up to 4 if we were rounding to the nearest ones place. Now, like our little guy in our book, if we just rounded this number and did 5.62 minus 2, we would have gotten our estimate as 3.62. That's a heck of a lot closer than 4, even though 4 is pretty close, right? So the less you round, the less numbers you round, or even what place you round, will give you a closer estimation, but this estimation kind of works, right? But if you were to just round 1, it would get you even closer to the actual answer. All right, let's just do a few from the bottom on page 34. So let's just do A for right now. 3.87 plus 1.99. Okay, so go ahead and either on your whiteboard or on a piece of paper, find an estimated answer and then check it against the real answer. So I'm going to estimate. You could estimate differently, but let's see if we get the right answer at the end. Okay, I went ahead and estimated to ones places. So that was 4 plus 2, which is 6. Then I actually came down here and did it, and I got 5.86. That's pretty close to 6, so I felt confident in my answer that it was right. If it had been crazy different from 6, I would have redone it. Okay, I actually don't have time on this video to do another one with you, but I think you probably get the idea. So if you want to do a few more from your textbook, feel free, have your parents check it, and then when you're ready and comfortable, go ahead and do workbook exercise 25.